Hi students, today we are learning the topic is eigenvalues and eigenvectors of the given square matrix. How to finding the eigenvalues and corresponding to eigenvalues and eigenvectors. Okay, see the first of all definitions. The important topic is first definition eigen matrix. So if A is square matrix of order n, lambda is the any scalar and I is the unit matrix of order n, then A minus lambda I is called eigen matrix or characteristic matrix of A, which is always square matrix of order n, and A minus lambda I and A matrix minus lambda into unit matrix, then there exists a matrix is called eigen matrix. Okay, see that here. Okay, that is A minus lambda I. So A is n by n matrix, square matrix. Okay, na minus lambda into this is n by n matrix, unit matrix. So observing here only diagonal elements may be changed, remaining same because only remaining zeros kada. Only unit matrix lo only diagonal elements only 1 1 with the lambda. Ante only diagonal elements we can change. Ante a11 minus lambda, a22 minus lambda up to so on, an minus lambda. That is equal to here. So this is a matrix. Only changed in diagonal elements, remaining same matrix in the A. So this is called eigen matrix of the given matrix A. Okay. So next definition, eigen polynomial. That is the determinant of eigen matrix A minus lambda I. That is data of A minus lambda I is called eigen polynomial or characteristic polynomial of A. And a given matrix data of A minus lambda A, eigen matrix A. Now finding det value. Det value finding means there exists a polynomial. That polynomial is called eigen polynomial. That is equal to here assumption. Data of A minus lambda is equal to data of this matrix. After finding that, we getting the one polynomial in lambda of degree n. This is a eigen polynomial. Okay. See the next definition. Eigen equation. So an equation data of A minus lambda is equal to 0 is called eigen equation or characteristic equation of the matrix A of order n. So already finding data of A minus lambda I, that is a polynomial. That polynomial is equal to 0. That is called eigen equation. So that is equal to here. Yeah, data of A minus lambda is equal to polynomial here. Already finding equal to 0. Then that is called, this equation is called eigen equation or characteristic equation. So next to eigenvalue. The roots of a eigen equation data of A minus lambda is equal to 0 of a square matrix A of order n are called eigenvalues or characteristic values or proper values or latent roots. Values and roots and both are same of A. And that means the above eigen equation now finding and solving that equation we getting the roots and the lambda value. Then lambda value is called eigenvalue of the given matrix A. So that is data of A minus lambda is equal to 0. This characteristic equation solving we getting the lambda value. The lambda value are called eigenvalues of A. That is lambda 1, lambda 2 up to so on, lambda n or eigenvalues of A. Next to eigenvectors. A non-zero column vector x is said to be eigenvector or characteristic vector of a square matrix A of order n corresponding to eigenvalue lambda if Ax is equal to lambda x or A minus lambda I into x is equal to 0, where 0 is the column, 0 column matrix, and Ax is equal to lambda x and A is the given matrix, x is any column vector. We getting the same lambda into x and then x is called x the column non-zero column vector x is called to eigenvector is corresponding to lambda, or another one which is can be write in the form a minus lambda I into x, and x common in right outside. Okay na, a minus lambda I into x is equal 0. This is 0 is the zero matrix. This is also matrix equation, and x is called to eigenvector corresponding to lambda. Here a minus lambda I into x is equal 0 is called to matrix equation. Using this matrix equation of finding eigenvector to the eigenvalue lambda. Okay na, this is the definitions: eigen equation, eigenvalue, eigenvectors. So next one, spectrum of a matrix. So the set of all eigenvalues of a matrix is called spectrum of A. And already finding the eigenvalues, then the set of all eigenvalues is called spectrum. Spectrum is one of the set. So that is equal to spectrum of A is equal to the set of lambda is. Lambda is the eigenvalue of A. So next definition, algebraic multiplicity of eigenvalue of a matrix. If lambda is eigenvalue of a matrix A repeated m times, then the number m is called algebraic multiplicity, that is am, of eigenvalue lambda. And after finding the eigenvalues how many times repeated. Not only unique, maybe one eigenvalue is repeated many times. So then the times is called, the number of times is called algebraic multiplicity of that corresponding eigenvalue. Okay na, how many times repeat avutundi, that is called algebraic multiplicity of eigenvalue. For example, here if A is a square matrix of order 5 and A is a order is 5 by 5 in it square matrix, then how many eigenvalues exist? Totally 5. Like matrix, given matrix order ఎంత ఉంటే eigenvalues అన్ని ఎగ్జిస్ట్ అవుతాయండి. సో ఆర్డర్ 5 కాబట్టి 5 eigenvalues. Assumption eigenvalues here 1, 3, 3, -1, -1. Okay na, for each eigenvalue we write algebraic multiplicity. Okay na, so that is equal to, first of all, algebraic multiplicity of eigenvalue 1. First eigenvalue how many time repeated? Only one time kada, and am is equal to 1. Next one, am of eigenvalue of 3. 3 is the eigenvalue, how many time repeated? 2 times here, so am is 2. Next one, eigenvalue -1, how many time repeated? 2 times, so am of eigenvalue of -1 is 2. Okay na, this is an algebraic multiplicity. So next one, so next geometric multiplicity of eigenvalue of matrix. The required number of arbitrary constants or the number of linearly independent eigenvectors corresponding to the eigenvalue is called geometric multiplicity, that is GM of eigenvalue. And how many vectors of linearly independent, or the required linearly independent eigenvectors, that is called geometric multiplicity of eigenvalue. And already మనం ఫైండ్ అవుట్ చేసాం చూడండి, సాల్వింగ్ ద సిస్టమ్ ఆఫ్ ఈక్వేషన్, ద రిక్వైర్డ్ the number of arbitrary values, that is n minus r. N is the number of unknowns minus r is the rank, that is called geometric multiplicity. And we are finding here n minus r is called geometric multiplicity of eigenvalue. Okay now, that is if n minus r is number of arbitrary constant, that is the geometric multiplicity values, and m is algebraic multiplicity of any eigenvalue, then 1 less than or equal to n minus r less than or equal to m. Ikkada small m is am, algebraic multiplicity, n minus r is geometric multiplicity, and geometric multiplicity of given eigenvalue is always between 1 to m. Okay, this is one of the condition. Okay, next one, trace of a matrix. We know that trace of the matrix is the sum of the diagonal elements in the matrix is called trace of the matrix. Okay, now that is sum of all principal diagonal elements of a square matrix is called trace of a matrix. It is denoted by trace of A. For example, the given matrix trace of A is 2 plus 3 plus 4 is equal to 9. This is a trace of given matrix. Okay, this is the geometric multiplicity and a trace. See the next one. Note. So the characteristic equation of the matrix A of order 2 can be obtained from lambda square minus s1 lambda plus s2 is equal to 0. This is another formula. So how to finding characteristic equation, det of A minus lambda is equal to 0. They directly finding det. That is one of the method. This is another method, the shortcut method. How to finding the characteristic equation, that is eigen equation of the given matrix, only 2 by 2 matrix. So here S1 S2 finding, substituting S1 S2 on that equation we getting the characteristic equation. So where S1 is sum of principal diagonal elements of A, that is trace of A, is find out shall S1. Next to S2, determinant of A, det find out shall. So substituting both here getting the characteristic equation. Okay, na? This is only 2 by 2 matrix. So next one, 3 by 3 matrix. The characteristic equation of the matrix A of order 3 can be obtained from lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Here finding s1, s2, s3 and so that is equal, where s1 is equal same trace of A. Okay, now next to s2, sum of minus of principal diagonal elements of A. Only diagonal elements ki minor find out child. So sum of the all minus of diagonal elements is equal to s2 value. Next s3 same determinant of A. Finding s1, s2, s3. Here substituting we getting the characteristic equation of the given matrix A of order 3. Okay. So next third one is the sum of the eigenvalues of a matrix is the sum of its principal diagonal elements. The sum of the eigenvalues is equal to trace of A anamata, meaning next the product of the eigenvalues of a matrix is the determinant of the matrix, and the product of the given eigenvalues is equal to the det of the given matrix. This is one of the two properties. Okay. For more videos, please do subscribe my channel, like and share it. Thank you.